What's up guys, George here, and this is Oh Wow That's Neato, and today we're talking about infinity and zero. Infinity, the concept of something being non-finite, going on forever, is a difficult concept to grasp. Imagine every single whole number added up, 1, 2, 3, 4, 5, etc. This would add up to infinity. Now imagine doubling all the numbers in the sum. 2, 4, 6, 8, 10, etc. This would also add up to infinity. Now, if you think about it, the second infinity would be twice as big as the first one, because all the numbers in the sum are twice as big. But on the other hand, you could say that it's smaller, because the second infinity leaves out all the odd numbers, 1, 3, 5, 7, etc. But they're still both infinity. Zero is a lot smaller than infinity, but it's very important in writing huge numbers that come close to infinity and in doing calculations involving them. Our counting system uses the same set of numbers over and over again to represent ones, tens, hundreds, and so on. The place where a 5 appears could mean 5, 50, or 500,000, but without a zero to represent an empty space, we wouldn't be able to tell the difference between 15, 105, and 1050. The ancient Romans didn't have a symbol for zero, so doing maths in ancient Rome was pretty hard. As we know, multiplying by zero gives zero, and dividing anything by zero warps the space-time continuum and destroys the universe. Actually, it just gives you infinity or math error if you're using a calculator. Now, even though zero and infinity are tricky ideas, mathematicians have found ways to use them to solve problems. Fire an arrow at a runner who is 100 meters away, and the arrow is going 10 times faster than the runner. Then by the time the arrow reaches the runner has moved 10 meters further. And by the time the arrow travels that extra 10 meters, the runner has moved on another meter, and so on and so forth. So, the arrow and runner should, theoretically, get infinitely close, but never meet. However, in a practical example, this would not be the case. Calculus is used in these situations by dividing up the flight of the arrow into infinitely small steps. The way these steps are added up, which is called integration, can find the exact location of the arrow at any point in its flight. If you like this video, then subscribe up there and like and favourite at the bottom and whatnot, do all that things. Follow me on Twitter. You can follow Oh Wow That's Neato for video updates and some facts that I find interesting, or you can follow my personal Twitter, which is also in the description, for personal things like that. So yeah.